Hey guys, welcome to your next video. It's Mr. Browse. This one's going to be on Objective 7.7a, represent linear relationships. The EQ is also written down there. How do I represent a word problem into a graph, a table, and equation? There's the word problem. You're going to have to go ahead and write that down. Alright, so now let's move on. We're going to start with the equation. Okay, so what we're trying to figure out is we have a word problem. What would the equation look like from this word problem? So we're going to have to highlight some keywords here. A bicycle rental company charges $18 to rent a bicycle plus $7 for every 2 hours. So this is something that you haven't probably seen yet. It says $7 for every 2 hours. So we know the form is going to have to be y equals mx plus b. So we've got to figure out what's our y-intercept, what's our slope, okay? So we know that that when we say each, per, and every, those are the key words that would tell us that what number is going to be our slope, right? So if we see the word every associated with a number, that usually means that's going to be our slope. So we see $7 for every 2 hours, right? But we need to figure out what would it be for 1 hour. So if it's $7 for every 2 hours, let's divide that and figure out what it is for 1 hour. So this would go into it 3 times. Add the decimal and the 0. So it's $3.50 for every hour. So that's going to make this equation start to look like this. 3.5x, okay? Now we have to figure out what our y-intercept is. So if we rented the bike but if we went 0 hours, we didn't even ride the bike at all, we just rented it, how much would it be? So that would be what I'm talking about right here is the $18. So that $18, you're paying that no matter what. If you decide to rent the bike and then you immediately return it, you still had to pay that $18 to rent it. Now let's talk about a table here. So we have hours as our x and the cost as our y, right? So if we rented it for 0 hours, we talked about this, it would be $18, correct? So now what you're going to have to do is we have to plug in these x values into the equation to figure out what it is. So if I plug in 1 to this equation, it's going to look something like this. 3.5 times 1 plus 18, right? So 3.5 times 1 is just 3.5, and then if we add 18 to it, that equals 21.5. So $21.50 is how much you'd pay for 1 hour. Now what about 2 hours? It would look like this, 3.5 times 2 plus 18, okay? So 3.5 times 2 is 7. So 7 plus 18 would equal what? 25, right? So I want you to do the same for number 3, or for 3 and 4 hours, okay? I want you to do the same for that and then show your teacher when you get to school. And then the last thing we're going to do is a graph. We're just going to draw a quick graph here. Alright, so we know our x is hours, so we're going to go up by 1 every time here. And then we'll go up by 5 here. And they have to go a little further. Okay. So I'll help you graph these first 3 numbers, and then these last 2 numbers you're going to have to graph on your own with the y values that you got, okay? So you can think of this table as an ordered pair. Remember, an ordered pair is a point on a graph, right? So 0 and 18. So 0 is right here, obviously. And so we're going to go all the way up to where we think 18 would be, which would be about right here. Okay, and then you have 1 and 21.5. So that would look right about here. 2 and 25 would go here, okay? And because we don't have lines on this, it's not going to be as straight as it would be on a piece of graph paper. But so you do 3 and 4, okay? So I want you to graph for the x value being 3 and the x value being 4. But essentially, once you find the equation to a word problem, the rest is cake, okay? You just have to plug in x values to get the y values, and then you just graph that table like it's an ordered pair. Thanks, guys.